Now imagine that you're living in a simple society, a society without watches, a society without any means that you understand today of telling the time. How would they synchronize a meeting with each other? So for example, you've got this farmer here and he says, I want you to come to my house for tea. What time's tea? 4 o'clock. No. We don't have clocks. I tell you what, when the shadow of that tree gets to that field over there, actually it's cloudy. When it gets dark, when does it get dark? You see the problems here? Without time, how did ancient man synchronize their working day? This has been an ongoing project for man since the time he was put onto this earth, of how he was to demarcate his days, his hours and his minutes, and make a system for himself whereby he could live and be productive and make use of his time, make use of the seasons, make use of the little he had in front of him to devise a system of time that would serve his needs, and then that would then evolve. So as it moved on through the centuries and the millennia, it would fit perfectly into our life as we evolved technologically, right? So I'm going to have a look at the Julian calendar and the Gregorian calendar, which are the calendars that really concern us today in the whole world. There are a plethora of other calendars around as well. They still exist, right? We still have the Chinese, the Indian, the Zoroastrian, we have the Jewish, we have the Islamic. But I'm going to look at the Gregorian. Why? Because that's the calendar that most concerns us. It's used all over the world, and even before it was used all over the world, it was the calendar that by far had the most influence on the world, even before it was fully adopted by the rest of the world. So when two people needed to synchronize a meeting in the olden days, they would normally say, meet me when the sun is this far in the sky, or meet me when this star, if it was nighttime, meet me when this star is pointing that way, or when the moon rises. But these things are all subject to change. The sun isn't always visible. It's cloudy sometimes. Sometimes the moon doesn't arise for a few days, or it rises very late. Certain stars don't appear in the sky. So everything was done by approximation and estimation, and man was very good at this. They could generally know how long it would be to get dark, even if there was no sun in the sky. They would know how many hours you'd have left till daylight, because they were in sync with nature. They were synchronized with nature. And it's very easy to become like this. If you don't if you're used to sleeping at a certain time and then waking up at a certain time, you won't need an alarm to wake you up. If you do get the sleep that you need, you'll wake up instantly at the same time. And generally, if you're aware of what's going on, you know the passage of time. You know exactly how long you've sat for. So ancient man was he was acute. His senses were acute to his environment. He lived as one with his environment. So he didn't really have a problem. Problems arose much later, and we'll have a look at when they arose. So how can time be measured? What are the different ways of measuring time? How did ancient man measure time? Well, there were a few ways. We had the moon. So you could look at the moon. The waxing and waning of the moon would give you the month. You could look at the sun. That would give you a Gregorian year, 365 days, as opposed to the 28 days of the moon, 29 days of the moon. You'd have looking at the heavenly bodies. So the ancients realized that by looking at certain parts of the sky against the fixed background of the environment, they could see stars rise, and those stars would move. They would shift over the course of the year. That's another way. By looking at the shadows of objects, you put a stick in the ground. If the sun rises this way, the shadow is this way. When the sun's overhead, the shadow is very small. When the sun moves this way, the shadow grows longer this way. Or trees, looking at trees, they cast shadows. People cast shadows. Then you have the seasons. So man very early on realized that seasons would follow. So if you were living in the temperate regions, you'd have mild winters with very small days and long nights, and then you'd have very long nights and short days and moderately warm summers. If you were more towards the tropics, you'd have equal days and equal nights, only a few hours variance, but generally your temperatures would stay the same. So it would either be hot and hotter, or it would be dry season and wet season. The monsoons, right? They're very regular. That's another way of telling the time. The tides come in twice a day. So you'd know, you could work out time by looking at the tides. Leaves. When do the leaves start to bud? When do flowers appear on plants? When does foliage appear on trees? You could observe that in spring. I've been observing this for the last 20 years. And I remember as a young teenager, it was around April, around the first week of April, where you could see the buds appear on the branches. I actually did the same thing this year, and I found that not much had changed. Now, if it had changed and the flowers were budding a month earlier or a month later, that heralds a bad sign, because that means that your climate's changing. But alhamdulillah, it was the same. That's not to say in other parts of the world it's the same, but here in England it's the same. So that's another way of knowing your seasons, knowing where you are in your year. Then you have the wind. Certain months are preceded by winds. You have the very hot winds blowing in the deserts from the south to the north, and then the north to the south, and in a very short amount of time you have extreme weather changes that can actually be quite dangerous for you as well, because the temperature variances can be up to 20 degrees in a very short amount of time. You have moist winds blowing in from the sea. Then you have dry winds, or winds blowing one way, winds bringing rain. Sometimes the winds would bring smells, so you know exactly what was the cause of the wind bringing the smell, right? Such as a marine smell, and that would herald a season. So that's another way would be, for example, the flooding, the annual flooding of the Nile, the River Nile. Rivers like that, they flood every year. So the flooding, it gets to a certain level and then it overflows the land, and that allows you to farm. And then it stays swollen, the river stays swollen, but then as the months pass, it starts to recede. So what the ancient Egyptians would do is they would have like these houses that were kind of wells really, but like a house built by the side of the bank, and the water would flow up to a certain level. They'd have lines, and as the water receded, they'd know what month they're in. That's another way. Bird migrations. There are seasonal migratory patterns where birds migrate from the tropics to the temperate zones, and then in the winter back again. That would give you an idea of time. Rains, when do the rains come? As mentioned, the rivers, it's because of the rains. Because in the head of the River Nile, where it starts from, you'd have the rains that would flood and bring the waters down. The monsoon, it's very seasonal. We have trade winds. The reason they're called trade winds is because you'd know what month to travel in. Those winds would allow you to travel towards the east, from the west to the east, and then there would be a reversal months later where you'd be able to travel back. That's another way of charting time. And the appearance of insects. Certain insects like the mayfly that only lives for a day. Like certain cicadas, they live for a decade or more under the ground in a state of like a grub or a worm, and then they metamorphosize into a big large cicada, and then they come out in their millions. It happens every decade or so. You can mark time by that as well. But then every year as well, like you have the emergence of ants in England. The big ants, they come out in late summer, so you can chart time from these kind of events as well. So these are the various means whereby ancient man could chart his day, his week, his month, and his year. But realistically, every village had their own clock. Why? Because imagine you have a sundial. The most basic clock is a sundial, a stick in the ground. Your noon is not going to be the same noon as another city. Why? Because you're slightly in a different part of the world. So if you're living, for example, in London, your Maghrib time, your evening prayer time, is 20 minutes earlier than it would be in Manchester. And again, that's 20 minutes earlier than it would be in Scotland. That's because your longitude is different, your latitude is different. So likewise, every city would have a slight variance. But that didn't matter because people couldn't travel far anyway. The average farmer in his whole life wouldn't travel outside of, the furthest he'd go would be to Market Town. He wouldn't have the means or the wealth to travel any further. Not to mention the dangers he'd encounter. Ancient travelers were very rare. And the ones that did travel were normally the sons of well-to-do people or noblemen. So it didn't matter whether one city had a slightly different time and you had a slightly different time. You couldn't get messages across. You couldn't travel in a day's journey that would make a difference in time anyway. The days that people had, they weren't repeating or synchronized as we know them today. They were set under different ways, and they were generally named after the gods of that particular religion that was naming those days. People would work by moonlight. So during harvest time, where the stock needs to be bought in, everything needs to be gathered before it rots, people would work day and night. The whole village would gather together and work day and night. And there would be like lunar societies up to very late, just before the gaslight. There would be lunar societies where people would get together on the white days, the 13th, 14th and 15th, where you could see at night. So you could have these meetings and fraternities and everything. And I remember during my stay in Saudi Arabia, where during the full moon, once a month, they would have this big gathering in the desert. They'd drive mileage out into the desert and lay out carpets. And they'd relax, serve food, maybe play football, something like this. Because it was the white nights. It was so bright that you could see everything in the desert. Now our body, we have circadian rhythms in our body. Our body is set in sync with creation. So when the sun comes up, we generally get up. When the sun goes down, we generally go to sleep. Now, what would happen if you take away the ability for you to see the sun? So you're now living in 24 hours perpetual darkness. If I put you into a cell where you have no idea of day or night, what would happen? Your body would still maintain some kind of a rhythm. It would know when to wake and when to sleep. Even though it might slowly start to move off what it was used to, but your body has an internal rhythm. That's the reason why if you do night shifts or if you do shift patterns that change, you play havoc with your body because it throws everything out of balance. And not only is there a 24-hour cycle in your body, there's actually an hourly cycle as well. Like in traditional Chinese medicine, certain medications, and science has verified this now, you need to give them at a certain time because medicines are potent. And don't forget, when you eat something, it's the liver that has to detoxify it and take away what it doesn't need and then send forth what's beneficial. And medicines, whether they are herbal medicines, strong herbal medicines, or Western medicines, a lot of them are toxic. So the body needs to filter them. But at certain times of the day, your body has different organs in your body have different functions. So your spleen will function at a certain time. Your liver will function at a certain time. So when your liver's detoxifying itself or regenerating itself or functioning, that's the wrong time to have that particular medication. And the Chinese worked this out thousands of years ago. We're just working it out now. So certain organs of yours regulate certain body functions of yours. So for example, your mood could be related to your spleen. Your memory could be related to another organ. So the kidneys, they say around 5 o'clock is the time when you should be relaxing because that's when your kidneys rejuvenate and its health generating properties flow through your body, qi flow through your body. But at that time, that's the time when everybody's scrambling to get home, right? So instead of relaxing, they're doing the opposite. So that's a whole science within itself, but it's fascinating to see how the Chinese worked this out thousands of years ago just through observations. And we're only starting to understand that now. So circadian rhythms is what your body has as an inbuilt clock that allows you to sync yourself in with the environment. So for agriculture societies, they needed to know more than the lunar year, the lunar month. They needed to know the solar month or the solar year, right? Because agricultural societies work on seasons. We have 4 seasons. Some areas in the world only have 2 seasons. Some have 4 seasons: spring, summer, autumn, and winter. So they needed to know when to plant, when to reap, when to sow, when to reap, when to harvest, when to watch out for certain predatory insects that would appear, like slugs and snails. Certain birds would peck at their crops, right? That's why we have scarecrows. So these things were very important for agriculture societies. So they needed a calendar. The Egyptians were an agricultural society. So it was very important for them because they had the annual flooding of the Nile, and that was the time where they had to get busy, because don't forget, Egypt is surrounded by desert. So it's actually the Nile Delta and the whole course of the Nile is a very fertile area. If you were to fly over it, you'd see the green around the River Nile. It's a beautiful sight to behold. So they needed to have a tight hold, a handle on a calendar or on time. So we mentioned they'd measure the Nile via rooms and the water level. They were actually the first ones to split the day and night. Today we know a 24-hour day. They worked out a 10-hour day and a 12-hour night. And there would be 1 hour here, twilight, and another hour here, twilight. So that would be the day, twilight, and that would be the night. They weren't concerned too much about the night. They were concerned about splitting the day up for work purposes. And then the night was split into 12, and they would measure that by the constellations, the 12 constellations of the zodiac that we have today. Now it's interesting, these charts can still be seen in the Egyptian, if you go to the tombs, because they believe that the dead would be resurrected and live. So then those charts are built on their walls and the ceilings of their tombs so that the dead can awake and know time and everything by looking at those. So they also had a water clock. A water clock that would be a basin that would have a hole in it, and water would drip out. And the water would, like an hour's worth of water would drip, and the basin would empty, and it would fill the second basin, and then the second basin would also drip into the third basin, and they'd have 12 basins. Now that's a rudimentary clock. It'll give you some idea of time, but the problem with that clock is that evaporation, and B, water that's under different pressure, it will flow even as a drop at a different rate. So if you have like a bowl that's very high, the pressure at the bottom will be greater than the top. So it'll force the water out faster. When you get to the bottom, it flows slowly. So it wasn't accurate. And those clocks actually, when the Europeans adopted them and other people, they actually made them into quite intricate devices, even with gears built in, right, to like show handles of a clock. But at that time, they gave you a rough idea of time, but it wasn't time as we know it, as in perfect to the second or the minute today. But it was enough for their purposes. So then the Chinese and the Japanese had candle clocks. They'd have a candle of tallow or of wax later on, and they'd have marks in the candle. 12 marks for each slot of the hour burning. You'd have incense candles. The same thing, you'd have a candle marked off, and how much burnt would tell you how much of the day had gone by. And they'd have different smells as well. So for this hour, you'd have this smell. For that hour, you'd have that smell. It could be rose, it could be jasmine, it could be whatever they had. And the Europeans actually in the beginning also used these methods until they mastered the art of clockmaking and took clockmaking to a new level. Now the early clocks were pendulums. So you'd have the swinging of a pendulum, and as that swung, there's a certain pattern, like the tick tock would measure time. That's one way of measuring time. Nobody would carry a clock with them, so they'd have town criers that would come out and cry the time, or they'd have gongs. The church steeple would have a bell in there, and then they'd strike the bell, and everybody in the whole town would know that, okay, the hour has passed. And traditionally, the only reason for marking the hours for such accuracy were to do with prayer times. Traditional societies were religious societies, and they would pray at certain times of the day, and that's the only reason why time was marked. Otherwise, there was no real reason to be marking time in villages at that time. Each city had a different noon, which means that their time was a bit different, and they had a different calendar based on the moon, because most calendars were based on sighting the moon. Now, the moon could be sighted one day in one city, another day in another city, and you'll see that even in Islam, this holds true. That if one city sees the moon on one day, it observes their ritual religious observation on that day, and whereas another city will observe it on another day. So it wasn't really until the 1800s, due to the advent of trains, the development of trains, because when trains came about in the 1800s, late 1800s, it was possible to travel like 3 or 4 days journey in one day. And when they got to the other place, then you'd really be able to realize, hang on a minute, my time is saying this, but when I go there, I can see that it doesn't match. So they realized that different cities had different times, so they artificially synchronized them. That's the reason why if you go to Bristol, you will, in the town hall, you'll see 2 clocks. You'll see the Bristol old time, and then you'd see the new time, the synchronized time also. Now, many people didn't like this, right? Give us back our noon, give us back our noon was a big shout. Everybody wanted their own time, because time is a very personal thing. Time is organic, right? Your time is not the same time as 60 miles that way, but today it is. So we've made these artificial constructs, and we no longer live by the seasons, and we no longer live by time even. Time is an artificial construct that's been forced upon you. Whereas before, there was a natural flow of time, external to you and internal to you, and you'd live in harmony. Whereas today, we're trying to control time externally and internally, where you have to get up at a certain hour. In the winter months, you'd probably be getting up later. Why? Because it was dark. You'd get up and there was nothing for you to do. In the summer months, you'd get up early. Your body was adapted to this, was used to this. On hot days, you'd get up and sleep at a certain time. On cold days, you'd do the same thing. And then the afternoon siesta. We no longer have the afternoon siesta anymore. The siesta, or kailula, as it's known in Arabic, is a time after your mid-afternoon meal, where your body would want to naturally slow down for an hour. Your mind slows down, you get sleepy, and you sleep and you rest and you recuperate. And today we know that it increases your productivity, increases your memory, keeps you more alert until evening time. But today we generally think that it's being less productive and it's a wastage of time for you to have the kailula. It's generally observed in hot countries, and it makes sense because that's the hottest part of the day, and you don't want to be outside in the sun. I mean, you cannot work on the fields when the weather is that hot. You can't work on building sites. So due to the trains, they split the world into 24-hour lines. And between each line was an hour's difference. So for example, they set it at GMT, so Greenwich Mean Time. So in Greenwich, you'll see in the observatory, they have a line. And if you put your foot on this side, it's like you've put your foot on the left-hand hemisphere, and your foot on this side, and your foot's in the right the right part of the world. But generally that can work in any spot on the earth, because the earth is round. Wherever you stand, you'll always be on one side. Your left foot will be on one side, and the right foot will be on the other side. But it's like a thing there, it's nice to stand there and take pictures and say, okay, well, I'm standing astride the earth. So it was agreed in a conference that they were going to set GMT 0 from London, and then anything left going towards the west would be minus, and anything towards the right would be ahead an hour. Now that doesn't reflect real time, because real time, as mentioned, is where is your noon. Because when you put your stick in the ground, and the longest, where the shadow starts to move, is where your noon is, right? Where the shadow gets to a particular spot and then it starts to move again, either getting longer or shorter, that is where your noon is, and that changes for every city. So most people lost their noons, but we're blissfully heedless of that fact today, because we think of time in a very artificial way, as opposed to how the ancients thought of time. But we think that That is time, right? So time is no longer organic, as mentioned. It's no longer organic. It's artificially given to you, and we've adopted it thinking that we're living an organic life. And then when we have them health problems, we don't understand why, even though we're trying to do everything perfectly. So the 7-day a week, I'm going to mention this later on, but the 7-day a week, it was actually developed by the Babylonians. And it was Alexander the Great who took it because he invaded the Babylonian Empire, which was under the Hachemenish Empire at that time. He defeated Darius and became master of the Persian realm, Persian Empire. And it was he who took it further east. So he took it into the west and to the east, to India and China and those lands. They ended up adopting this as an indirect result of Alexander the Great conquering Babylonia. The Etruscans, which were the former Romans, they were actually the Romans, it was before the Roman Empire. Now they had what was known as an 8-day week, which was different, and then they made it a 7-day after their conversion to Christianity, which we'll look at as well. So just a bit about base 60 counting and base 10. Today we know counting as 1 to 10, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you had the 11, and then it starts again when you get to 20, and then 21, and then it's a base 10 counting system. Sounds simple, 5 fingers. If I count 5 and 5, it's 10. It's logical enough, but ancient man didn't think like that. The first recorded counting we had goes back to the Sumerians. Now the Sumerians counted in a system known as base 60. How did they arrive at this system? So you have a hand, and in your hand you have 3 segments in each finger. So they counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, and then you have 5 digits, times 5 is 60. So that's how they would work their mathematics. And 60 is a number, a whole number that's divisible quite easily compared to other numbers. The Sumerians didn't have fractions, and their mathematics wasn't as advanced as later people, and certainly not as advanced as we have today. So as a result, they kept it at 60, and it suited their small business transactions and the workings of their day and the year and everything quite fine. So that's the reason why we have 360 degrees in a circle, 360 degrees in a circle, and then you have 60 minutes in an hour, because the hour was 24, then within the hour 60 minutes, and then within a minute 60 seconds. Now all of this is divisible. That's the reason why they use base 60. And the Romans took it from the Babylonians, and obviously we got it from the Romans. So this way of thinking has come down to us from the Sumerians, and it's worked perfectly, so there's no reason to change it. That's the reason why when you have a clock, you don't have up to 100 minutes, you only have up to 60 minutes before the hour changes, and it goes to 24 hours. So there are 12 divisors of 60, but only 9 divisors of 100. Similarly, there are 24 divisors of 360, but only 16 divisors of 1000. So it's pretty clear how advantageous these numbers are in subdivision of time, work, angles, and etc. So now we'll have a look at the Roman calendar. So as I mentioned, every area in the world, every religion had their own calendars. Now calendars suited 2 purposes. One was the measure of the seasons and time to aid them in their agriculture, and 2, to observe religious festivals. So before we have a look at the Roman calendar, which is what I really want to talk about today, just want to mention what would be the most natural way for any man to look out and observe nature and make a calendar. What would be the most natural way? It would be the cycle of the moon. So once a month, man sits outside after dark, after he's done his work, and he's sitting down relaxing now, and he looks up into the sky and he sees this large object rise. And it's a very faint crescent, and it travels along the sky and it's gone. And every day he observes that at a time, 15 minutes or an hour, remember he didn't have those 15 minutes, but he knew that at some point that same moon would rise and it would get larger, and it would travel across the sky and it would set, and then it would get to a stage where it was now a complete circle and it was bright and he could see at night, and then it would start to wane and then it would die, and then it would be reborn again. And he saw this as a pattern that repeated again and again. And he worked out pretty quickly that that pattern was 28 or 29 days. So when he had to mention to somebody, when was your son born? My son was born 5 moons ago. When did you get married? I got married 24 moons ago. When will we conclude this business meeting? When will you give my money back? 2 moons from now. So you see where this is going? That's the earliest calendar. So it needed to be recorded. As well as for religious observations, you also needed to record these dates so you could do your financial transactions and man could live. As man settled down, when he left his hunter-gatherer ways and he became an agriculturalist, he started to then barter and then do business, and societies became more sophisticated and complex. So their simple calendars needed to evolve, and they did evolve with the times. So by the time of the Romans, they were using a lunar calendar. And it was actually Romulus in 750 BCE, he made the first civil calendar, and he made it a lunisolar calendar, which means that he now had to match the moon with the Gregorian year. So those 11 days, he had to fill them in somehow. So the Romans had a fixation with the number 10, right? As you know, when it comes to numbers written in Roman, you have like the 1, and then 1, 1, which is 2, 1, 2, 3, 1, 2, 3, V. V is half of X, X is 10, so 1, 2, 3, 4, and then the 5 is the V, and then it's the 6 would be V1, and then it carries on, and then you'd get to 9, and then X would be 10. Right? So when they wanted to show 20, it'd be XX. That's why very quickly the numbers became very large. At that time, the Romans had a fixation with the number 10. So what he did is he made his day 10 months fixed around the moon. That gave him 304 days. That left over some days. 2 months approx were left over. So those months actually didn't exist, right? They were intercalary days, and they officially didn't exist on the calendar. So they only had 10 months on their calendar, not 12 months as we knew them today. So the Romulus calendar, based on the 10, was, so the first month started in March. Most calendars, their months start in March, which is the first day of spring, when you have the new year. Right? That's the time when calendars normally start. Today our calendar starts in midwinter. It didn't then. So the first month would be Martius, Aprilis, the second month, Maius, the third month, Lunus, Quintilius, Sextilius. Then it would be September, October, November, December. Some of these names are familiar to you. The first few months were the names named after their gods, and then the rest of the months as we know them today. So the year began in March, named after Mars, the Roman god of war. The start of the spring life begins, right? Mars was the god of war. The rest are named after the numbers of the month. There was no January or February, as mentioned. October means 8, oct. It means 8, right? But it doesn't reflect the 8th month today. Why is that? Because at that time, it was the 8th month. October, and then November, December, because there was no January, February. Today we've got January and February, so we've just pushed it down, so our 10th month still retains the same name, even though it's 2 months down now because they put January and February. So it's October. They were so January and February were perceived unlucky, so that's the reason why they never gave any names to those 2 months. They were nameless months. So that carried on for a while. And then we had the second king of Rome, who was Numa, in 713 BC. At his time, the Romans thought odd numbers lucky. So all of the months that were 30 days, the 10 months were 30 days, based around the moon, they were changed to 29 days. So now we have more days left over. So they made more months. Now they made January, from Janus, one of their gods, 29 days, and February, from Feber, means to purify, which was 28 days. So now they had 12 months of 355 days. That was their calendar, 355-day calendar. So again, it wasn't a full year, so they added a leap month every couple of years. Every few years they'd have to have a leap month. So the Numa calendar, what did it look like? So now you had Lenorius and Feborius. So 2 new months have been added. Then you had Masidnius, which is an intercalary month once in a while. Marcius, Latin for wages. That was the time of the year where wages were given. Then you had Martius, Aprilis, Lunius, Quintilius, Sextilius, September, October, November, December. So they had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 months of the year now. So now they've got the months and they can play with adding extra days every few years or a month every few years to fill the calendar. But what about the names of the days? How were the days of the week for the Romans? The Romans actually never had days of the week. They had what was known as an 8-day cycle that would repeat. They were based on market days. So you'd have a market in this town, a market in this town. That would be the first day, second day, third day, fourth day, fifth day, and 8 days. And 8 days would be the day of rest. And each town would have a different first day, second day, third day. So the days would be different for each town as well. And it would be a revolving 8-day week as opposed to our 7-day week. But it didn't really matter so much because the calendar was off anyway. It wasn't exactly the same calendar that we knew today. So a feast day would be marked by the last day, and that's where we get the name, that they would name it Red Day, and today we get the name Red Letter Day from that day. So the first day of the month was called Calidus. We get the word calendar. A cry would call calendar in public. So then a cry would be sent out and he would tell everybody this is the first day of the month, and we get the word calendar from there. So intercalation, how did they use intercalation? The intercalary month would cause problems. Those responsible wanted certain persons or rulers to stay in power. Who was responsible for fixing those days? It would only be the priest at the behest of the king, because there was complex mathematics involved in sighting the moon. Most people could sight the moon, but to know the exact number of the days of the month and where the moon would appear, the best time of observation, needed some intelligence, right? So only the educated elite would do that, and from that it would be the priestly caste. It was their responsibility, and it was for them because they would fix the religious holidays, right? So, but this became a plaything in the hands of the kings. So, if they wanted a certain ruler to stay in power, they would just lengthen the year. If they wanted, like for example, wages to be delayed, they would just lengthen. So wages would get delayed. Some people would lose and some people would save money. So intercalation has always been problematic because it's been a plaything in the hands of people. And what it does is that people normally make a mess of calendars, and everybody has really made a mess of calendars at some point because of intercalation, and it mixes up your dates, and datings become very difficult. And a lot of religious observations in every religion were based around specific dates, and if you miss those dates it becomes sinful, or if those celebrations were done earlier, again it would be problematic. So by the time of Julius Caesar, which is now 46 BC, the year had shifted out of alignment due to this tampering. March was in spring, but by Julius's time, March was in winter. So where they had set March and worked out the intercalation where March would stay in the spring, it had actually drifted backwards and gone into December, into the winter. So Julius Caesar wanted to get the March back into the spring equinox. So in 46 BC, he added an extra 80 days, which is around 2 months. So the year became 445 days that year. And it was called the Year of Confusion. This actually brought the calendar back into alignment, but caused a lot of societal problems where people were saying, we will not give rent because why should we give rent when it's been changed? We don't need to give extra wages. Why should we give extra wages? Why are wages being delayed? So all of these sorts of problems started in that particular year. That's why it was called the Year of Confusion. So he actually made the calendar now 365 days a year, and every 4 years he added a leap year because they knew that the way the earth spinned, there would be like a 25 extra, and that over 4 years would become a day, 24 hours. I call the 6 hours, the difference. So every 4 years a leap year would be added. That's fine, right? That's what we do today. But actually what happens is there's an 11-minute difference. So over a long period of time, that 11 minutes also adds up, and then your calendar's drifting again, which is exactly what happened after hundreds of years. Now the Julian calendar looked like this: Lenorius, Februarius, then the leap year when it needed to be. Martius, Aprilius, Lunius, Julius, Quintilius, Sectilius, September, October, November, and December as we know it today. So the Senate was so happy with what Julius Caesar did, that he had fixed their calendar, that they named Quintilius Julius. That's where we get the word July from today. After he died, they somehow forgot what year the leap year was supposed to be and started to do it every 3 years. So by the time of Augustus in 8 BCE, the calendar was out of alignment. He corrected the mistake over 16 years. So by his time, he had also realized that the calendar had gone out of alignment. But what he did is he corrected it over 16 years as opposed to straight away. So instead of causing problems, he did it very, very slowly, which was actually a smart move. The Senate was again so happy that they renamed Sextilius to Augustus, which is the month of August, right? And because July has 31 days, the only 2 back-to-back months in our calendar that have 31 days are July and August. That's the reason why, because Augustus didn't want to be done. No king wants to be outdone by a king, especially a king that's been in the past, right? It's very easy to get one over him because he's not there to get you back. So then, in 321 CE, we had Constantine. He was the first Christian emperor. He was the first one to embrace Christianity, and it was a turning point for the Roman Empire, where it started to become Christian now over centuries. He implemented the 7-day week from the Babylonians. So how did the Babylonians come to the idea of a 7-day week? Well, they looked at the heavenly bodies around them, and they saw that the stars were fixed in the firmament. They would twinkle and they would appear in the same pattern for most of the year, but the whole pattern in its entirety would shift, right? But it would stay fixed. Because the stars are so far away, even though they're moving away from each other, we'll never know. It takes tens of thousands of years, thousands of years before you can see small movements. Whereas they observed that there were some stars that would actually move and then appear to move backwards on themselves, and then move again. And they called these stars wanderers. In Latin, that would be, or in Greek, that would be planet. That's where we get the name planets from. Now, they could only observe up to Saturn. I think it was Jupiter. Saturn was the furthest planet they could see with the naked eye. Uranus was the first planet discovered by a telescope by Herschel. Before that, we only could see up to Saturn. So that's the sun, because the sun moves. The moon moves. That's 2. 3, it's Mercury. 4 is Venus. 5 is Mars. 6 is Jupiter. 7 is August. That's 7 wanderers in the sky. That's 7 objects that move, and they named their days around those 7 objects. So that's where we got the week from. So what the Babylonians did is they actually named their hours after these planets. So we have 7 planets into 24 hours. It doesn't go. So they would have, like, the first hour of the day would be this planet, the second hour would be this planet. They'd go through the 7, and then it wouldn't fit, so they'd add them again. It wouldn't fit, but they saw that after 7 cycles, that's 49 days, it would fit. So this is the pattern that they made into the days of the week. So we have Saturn Day, which was Saturday, Sunday, which is Sunday as we know it, Moon Day, right? Like in French, you'd hear these like Mardi, and then Mercredi, right? Mercredi in French is based on Mercury. Then Jupiter, Jeudi, and then Venus, Vendredi. And then later it was changed over into Anglo-Saxon and German gods. So for example, Tuesday became Tu, right? From the Nordic god Tu. And Wednesday, Wooden, which was Odin's day. Odin, the father of Thor, which was Thursday, Thor's day. And then Free was the wife of Odin, the mother of Thor, Free day. So the gods just changed names for the days of the week. So Easter is interesting now. Now, because the Romans became Christian, they had to observe certain festivals that the Jews observed, and at a certain time. Like, for example, the resurrection of Christ was very, very important for them. And it had to be done at a particular time because according to the lunar calendar, when he was resurrected, it was in spring. And if you don't fix your dates, even in today's calendar, if you don't fix it, it will drift. The lunar calendar will drift, and you'll end up celebrating. It doesn't matter so much for Muslims because we have a 32.5-year cycle where our Ramadan cycles through the seasons, and you get them like in the summer and then in the winter, and it cycles. But whereas they wanted to fix Easter, Passover, it was actually the Passover festival at a particular date. So what they did, Easter was a pagan festival and Passover was a Hebrew festival. So they decided to fix it because Passover actually happens on the full moon of I think it's the first month of the Hebrew calendar, which is the month called Nisan. So they wanted to fix that first month because it happens in March with their own beginning of the year, the spring equinox, which is a pagan festival celebrated at the spring equinox called Easter. So they wanted to fix both of them together. So they decided it was Easter will be celebrated on the first Sunday after the first full moon on or after the spring equinox. So Easter always has to fall there now. So that's where the date was for Easter was fixed. So they measured the date for spring equinox on that year as 21 March and fixed it as such. So when they came to the conclusion that they wanted to do this, the date actually happened to be, the spring equinox had to be the 21st of March. And because it was the 21st of March, they fixed it. So ever since then, our spring equinox doesn't change. It's always the 21st of March. Because whenever they intercalate, every 4 years when you intercalate, it will always keep your spring equinox in the same day. Now the Julian calendar was 11 days too long, and in the future people noticed that the spring equinox wasn't on the 21st of March. And if Easter was dated as the date, then Easter was celebrated on the wrong time. Eating while fasting was a sin. As pointed out earlier, there is an 11-minute difference in the Julian calendar. So over a long period of time, a few hundred years, again your Easter, the spring equinox, the 21st of March, is going to drift. Your spring equinox is going to drift. So it no longer remains on the 21st. Now that was a problem because Passover and the day of Christ's resurrection where they had to fast was a religious observation. And if you're fasting at the wrong date, it's void. And if you're eating when you're supposed to be fasting, it's a sin. So again, that became a problem. So what did they do? Enter Pope Gregory in the 13th century, 14th century, 1502 to 1585. So by the time of Pope Gregory, now the spring equinox was taking place 10 days earlier. So those 11 minutes that are counted, and now the spring equinox was 11 minutes earlier. So the Pope took out 10 days from the calendar from November 4th to November 15th. So he just totally took out those 10 days, right? Those 10 days just disappeared off the face of the calendar. They didn't exist anymore. So this created a big problem because it was actually around about that time, straight after we had what was known as the Christian Reformation, where the church split. You had the Protestant movement and then the Catholics, which was the original church, the largest church that had killed off all the other smaller denominations. And that within itself split due to many reasons, that the excesses of the church. And the other movement, which was the Protestant movement, didn't want to adopt it. So this created problems for hundreds of years. In fact, people didn't adopt the Pope Gregory's Gregorian calendar. In one country, you could have different villages. The north would have a slightly different calendar. The south would have a different calendar. Even sometimes within your same village, parts of your village would have a different calendar. Certain households would want to follow a different calendar. Just like you have 2 Eids today. It took the UK 200 years to fully adopt the Gregorian calendar because the church, the English were the Church of England, Henry VIII, the founder of the Church of England, which is an offshoot of Protestantism. So they weren't going to follow the Catholic Pope Gregory on his ideas of the calendar. And the Orthodox countries like the Russian, the Greek Orthodox Church, the Russian Church, and I'm not sure if it was some of the Middle Eastern churches. Right, it was only as late as the 1920s that when they adopted these particular dates, and even now they hold their own independent calendars. So Pope Gregory also what he did now, because don't forget it drifts by 11 minutes. So that 11 minutes causes problems. So they had to again reformulate the calendar and work out an even tighter calendar to keep it fixed for a longer period of time. So they had the leap year, but it was a bit different now. They skipped centuries if it was divisible by 400. So for example, the year 1600 was a normal leap year. 1700 wasn't. 1800 skip. 1900 skip. 2000 leap year. 2001 skip. So that's how they decided to work out the calendar. So any century that was divisible by 400, skip it. So that is the evolution of the Gregorian calendar as we know it today. So it started way back with the early Romans, who took ideas from the Babylonians and from the Egyptians. The Babylonians themselves took it from the Sumerians, who were the first settled civilization to give us our day, our minute, our month, and our year. And even today, our day isn't perfect. And today we have atomic clocks, and atomic clocks actually are more accurate than the revolving of our Earth on its own axis and around the sun. Because before, the most accurate thing we knew is the sun, right? You knew where the sun was every day, and it doesn't change. You know where the moon is, it doesn't change. But in fact, it does slightly because of many variables. Whereas our atomic clocks today, which measure based on oscillations, and those oscillations are the same anywhere in the universe. So your time is uniform. And it's going to be more uniform than the time we get from observing the sun or the moon. Because the moon and the sun are like, how do we measure? Where do we measure from? For example, we have the sidereal month. In the previous lecture I mentioned that. The synodic month. We have the sidereal day. We have different measurements in the day. Where is your noon? We have the tropical year, the sidereal year, the animalistic year. The spinning of the earth is slowing down. The moon is getting away from the earth. Every year it moves a bit further. Our axial tilt wobbles ever so slightly. We proceed. We have precession, right? We have a thousands of year precession that changes. We have the gravitational effect on planets. They affect our motion around the sun, even though they're so far away. We have perihelion and aphelion. You travel faster when you're on one side than opposed to the other side. So your day will change, your year will change. Slight variations in it. These things mean that we can never have an accurate calendar. So actually working on a calendar and keeping that calendar in sync with what's actually happening out there in creation is a very difficult task. And man is not perfect, and nothing man does is perfect. Hence why his calendar isn't perfect. The only Allah subhanahu wa ta'ala is perfect, and whatever Allah does is perfect. Ours is to basically understand when Allah says He's given us the sun and the moon as signs, and to demarcate our day and our worship. So we have the moon that we use in our worship, and we have the sun also that we use in our worship. Some of our festivals are moon-based festivals, based around the moon, and then our daily 5 days of prayer are based around the sun. So the Julian calendar was an evolution, as you can see, borrowed from way back from its roots go back to the Sumerians, and even further when man first started. So I hope you've really enjoyed and benefited from this lecture. Thank you very much for watching. If you have any questions, you can always write to me and I'll try my best to answer them. Thank you very much for watching.